Alright, so the next important skill that's very important for talking about our solutions is being able to make a dilution and being able to make that dilution into a known concentration. So if we make a dilution, we're essentially lowering the concentration of that solution by adding more solvent to that solution. So the ratio then of the initial and the final solution volumes can be written as volume 1 would be the initial and volume 2 would be the final volume. So in our dilution process, the amount of the solute remains constant. Only the volume is going to change, so our volume is going to be increased in the diluted sample. And so this allows us to set up an equation that our mass of our first solution times the volume of that solution is going to be equivalent to the mass of the second solution times the second volume. That this is going to be related to a constant. So our dilution equations then can be generalized to other concentration units as well, including things like parts per million or percent solutions. So we can use a more generic formula to measure these concentrations using the concentration term C. And so we can say that C1 times V1 equals C2 times V2. And we can use this general equation then to calculate how you can make different dilutions of the concentrations that you want to make. So our dilution equation, M1V1 times M2 equals M2 times V2. M1 and V1 is referring to the initial concentration and the initial volume of the solution. And M2 and V2 refer to the final concentration and final volume. So you'll either see it written as M1V1 times equals M2 times V2, or you might see the M replaced with a C for concentration. Both of these are going to be standard formula that you will see. So this equation is to be used for only calculating the solution molarities from a dilution. It's not used for calculating moles in stoichiometric problems where you're actually looking at the chemical equation and calculating moles. That you're going to use the formula weight to calculate your mole concentrations. So our M1V1 equals M2 times V2, only useful in making dilutions. That's our dilution equation. So we've got a couple of questions that we can try. So if I add water to 100 mils of a 0.15 molar sodium hydroxide solution until the final volume is 150 mils, what will be the molarity of the diluted solution? So I'm just going to bring my little paint screen down here. So we know that our equation is going to be M1 times V1 equals M2 times V2. Sorry, my writing on the computer is a little bit crazy. So if we're looking at our equation, we can see that our V1 is 100 milliliters and our concentration is 0.15 molar of the sodium hydroxide for the initial concentration, or C1 or M1. So we can fill in these values for the first initial concentrations. So once written out, we've got 0.15 molar solution times 100 mils. So this is our M1 times V1 equals M2 is our unknown. So that's going to be the new molarity of our diluted solution. And our final volume in the diluted solution is 150 mils. So this is pretty easy to solve. We just need to divide both sides by 150 to get rid of the milliliters on this side. So notice, you just want to make sure that your concentration units are the same on both sides for both the concentration and for the volume. So we've got molarity on both sides, big M, and that's what we want, molarity. And then both volumes are in milliliters, so we can just leave them in milliliters. That's fine because they match. So once we do this, we can see that our milliliters is going to cancel out on both sides. And our answer is going to be left in molarity, which is the concentration we want for our second concentration, or M2. And so our final answer is that the concentration of the final volume is 0.1 molar. So note that when you make a dilution, your initial solution is more concentrated than the final one. If you're adding more solvent, you're diluting your final concentration. So that's a check that you can do for your problem set. So you should know that M2 should be a lower concentration than M1. And in this case, that matches. It's a lot lower. This was 0.15, and now you're down to 0.1 molar. So this is our final answer. So now let's take a look at the second equation. So if we have a stock solution of 3 molar sodium chloride, how much of the stock will I need to add to make a 250 ml solution of 0.5 molar NaCl? So in this case, we know M1, but we do not know V1. V1 is what we need to calculate. We know M2, and we know the volume of the final dilution is 250 mils. So we can set up our equation. Again, it's M1 times V1 equals M2 times V2. So we know our concentration for M1 is 3.0 molar. We don't know what our concentration of V1 is. That's our unknown. Concentration of M2 is 0.5 molar. And the final volume is 250 milliliters. So for this equation, we just end up having to solve for V1. So we'll divide both sides by 3 molar. The molar units will cancel out. Our answer is going to be left in milliliters. This side, the entire concentration unit will be canceled, and we will have solved for V1. So our final answer is 41.6 milliliters. We can see that this volume should be smaller than our final concentration since we're doing a dilution again. The final volume's got to be higher than the initial volume to make a dilution, right? Because we have to add the solvent to the system. So we know if we add 41.6 mils of our stock concentration of a 3 molar solution, that it will dilute it to 0.5 in 250 mils. So those are dilution problems and some practice doing those.